Hey everybody, I hope that you are safe and healthy and learning to appreciate your personal space like this guy.
Hey, welcome back to Personal Space. I'm your host, Philip Jacobs, and let me tell you, I care about my personal space. Whoa, whoa! Hey, who's around me right now? Who's around me?
Before we get started, I want to mention that I'm planning on posting the next homework set, Homework 4, on Blackboard on Monday. So that's March 30th. I'm going to give you a little bit more than a week to work on it. So we'll have that due on Wednesday, April 8th. And that'll be due at midnight Eastern Time. So plan accordingly for those of you who are in different time zones. If you're going to have any problem meeting that deadline due to travel restrictions or anything, please let me know and we'll try and be flexible in working things out. For today, what I'm going to be talking about in this video are the formulas for the benefit cost ratios, as well as how we would actually use them to do a benefit cost analysis and compare mutually exclusive projects. So there are two formulas for benefit cost ratios. They're both something that can be adjusted to be expressed in terms of present, annual, or future worth terms. But one of them is called a conventional benefit cost ratio, and the other is called a modified benefit cost ratio. So the conventional benefit cost ratio is the one that we're going to use in this class. And the way that this works is, like we've said, benefits on top, costs on the bottom. And if you put it all in present worth terms using our standard sort of model where you have a capital investment and then you've got some sort of a market value in the future or a salvage value, and then O&M costs in the meantime, as well as ongoing benefits, then you would have something like this, where the present worth of all of our benefits are in the numerator, and then in the denominator, we've got the capital investment. Subtract off the market value in present worth terms, and then add the present worth of all of your operations and maintenance costs. So this is the place where it's a little bit tricky. This is the only really nuanced thing that you need to know, is that we take the capital investment and then we subtract off the present worth or the worth of your market value or salvage. The reason why we do that is because we think of that as kind of the capital recovery. It's actually at the end of life, you're returning back some of the value from that capital expenditure, and it's effectively reducing the cost of that capital investment. So you'll see that if we put this on annual worth terms, you'll see something like this, where in the numerator, we've got the annual worth of your benefits, and then in the denominator, you've got the capital recovery amount plus the annual worth of your O&M costs. And so if you remember, the capital recovery amount was basically just the annual worth of the difference between the investment I and the salvage value at the end of life. So that's the only thing that you really need to worry about, or the only thing that can trip you up, is just remembering that you are going to take the salvage value and you're going to put that in the denominator by reducing the cost instead of having it in the numerator and treating it like it was a revenue at the end of life. The difference between the conventional benefit cost ratio and the modified one is that the modified benefit cost ratio, it takes the worth of your O&M costs, all of the costs and expenses that you're bearing over time, and it actually puts them up in the numerator. So this is kind of counterintuitive, right? But what it turns into is that in the numerator, you just have the net benefits because it's taking your benefits and it's subtracting off the cost from that same time period. And so the numerator just has the net benefits of all of the future time periods throughout the lifetime of the project. And then in the denominator, all that you're left with is the capital recovery. So in present worth terms, in the first equation, you can see that in the denominator, we've got the capital investment minus the market value or the salvage at the end of life. And then in the annual worth equation, in the denominator, all we've got is the capital recovery amount. So this kind of violates the way that we think about what a benefit cost ratio ought to be. And so for the purposes of this class, I'm mentioning it because it's in the textbook, you're going to see it, but we're always just going to use the conventional benefit cost ratio in this class. So that's what you should assume as a default, and that's going to be what you need to get the right answer on the homework sets That's what you're going to need to get the right answer on the exam. When we're using benefit cost ratios to make decisions and compare multiple projects, we've got an issue. Okay, so remember when we were talking about the internal and external rate of return, we sometimes would get inconsistent rankings depending on whether we were using the worth method or a rate of return metric. Well, because benefit cost ratios are a ratio, they're sort of like a rate of return in a way. It's basically saying, the benefits of a project are 3 times more than the costs. But what private companies want to maximize is their profit, right? And that's in absolute terms and not in terms of a rate of return. So we've got the same issue here as we did when we were using the rate of return to make decisions, is that the gold standard was always the equivalent net worth, not the rate of return. And so we don't think about the equivalent worth and the rate of return giving inconsistent answers. The way you want to think about this is that sometimes the rate of return can give you the wrong answer. And we've got the same sort of situation here, where if we're just comparing the benefit cost ratio of 2 different projects, we might get the wrong answer in terms of which project we would actually prefer if we were thinking about it in actual worth terms. So as an example here, just a really simple example, I don't even need to write anything down. Imagine that we're considering 2 different projects. We're either going to build a bridge to cross a river, or we're going to operate a ferry to get people from one side to the other. Okay, so you can imagine that the ferry is probably less expensive in order to operate it. It's not going to have to span the entire river. So it's going to be cheaper, but it also provides less benefit. It can't take as many people across at once. Once it is in the middle of the river, no one else can load, so it's going to take longer to get there. And so the benefit is going to be smaller too. And so we want to just ask the question, right? Can the benefit cost ratio of the ferry be greater than the benefit cost ratio of the bridge, but the net present worth of the bridge be greater than the ferry? And so first, if you want to think about that question, we just want to ask, what does that criteria mean translating it into mathematical terms? So if we have B sub f being the benefit of the ferry and C sub f as being the cost, and then B sub b as being the benefit and C sub b as being the cost of the bridge, then the first criterion, saying the benefit cost ratio of the ferry should be greater than the benefit cost ratio of the bridge, is this B sub f over C sub f greater than B sub b over C sub b. But then the second expression, that the net present worth of the bridge would be greater than the ferry, says that B sub f minus C sub f is less than B sub b minus C sub b. If we look at those 2 expressions, algebraically, there's no way that we can show that both of these can't be true simultaneously. There's no reason that they both have to be true, but they both can be true. The example of this would be if we just suppose the benefits for the ferry are $3 million, whereas they're twice as much, $6 million for the bridge. And for the ferry, the costs are $1 million, and the bridge would cost $3 million. Then in this case, it's really easy to see the benefit cost ratio for the ferry would be 3. For the bridge, it would be 2. But in present worth terms, the net present worth of the ferry would be 2 million, whereas for the bridge, it would be 3. So we're going to use incremental analysis, just like we did with the rate of returns, in order to figure out how we need to reconcile this particular issue. So just like before, if we're using incremental analysis, the first thing that we need to do is identify a baseline. And so we're going to consider the baseline, just like before, to be the project that has the smallest initial capital expenditure. So in this case, we would choose the ferry. And then what we're going to do is calculate the differences or the deltas between the benefits of the project and the delta between the cost of the project. And then if that incremental difference has a benefit cost ratio that's greater than 1 or a positive worth, then the comparison project is the one that we're going to choose. That's it in terms of how we're going to use benefit cost ratios to choose between mutually exclusive projects. In the next video, we'll show some example problems. Thanks.